Okay, continuing our section 7.2 notes, we want to continue talking about these qualities of our statistics. So the second quality is the fact that the size of the population does not affect our precision. And it does seem a little bit surprising to make that claim at first. Like, how could the level of precision for a survey in a town of 10,000 people be the same as in a whole country of 210 million people? How could we possibly have the same level of precision for a very small and a very large population? So here is the kind of analogy example that your book gives, which I think is a good one. It says the 2 bowls of soup represent 2 populations. One bowl is small population, one is a larger population. Your goal is to taste each soup. You want to take a sample from each population and decide whether you like it or not. So that's your sample, is your spoon. So it says if both bowls are well stirred, then the size of the bowl shouldn't matter. If you're using the same spoon, the same sized spoon, you should be able to get the same amount of taste from either bowl. So what you want to know here, the whole idea here, is that your precision relies on the sample size, the spoon, not the population size, the bowl. That leads us to the third quality here, which is the idea that larger samples produce more precise estimators. So if you take a bigger sample, if you use a bigger spoon, that's when you should be able to be more precise. The size of the bowl which it came from is besides the point. So surveys based on larger samples have smaller standard errors and therefore better precision. We can find and calculate bias and standard error fairly easily as long as we meet these 2 conditions. The first one is the sample has to be randomly selected. And the second one says if you do it without replacement, then the population must be much larger than the sample size, at least 10 times as large. So how we're going to write that is the population is going to be N, and we're going to say that has to be at least 10 times bigger than the sample size. You're going to see us write that in section 7.3. If we have these 2, if we can say check it was randomly selected and check the population is more than 10 times the sample, then we can know these 2 pieces of information. We can know automatically that the bias of p hat is 0. What that again tells us is that p minus p hat gives us 0. And another way to write that, if I just rearrange it, if I move this to this side, what that tells me is that p and p hat are the same. Again, we expect to hit the true value. This was my estimate. This is the true value. I expect to hit the true value. And then, as long as we hit these 2 characteristics here, we can also have a formula where we will just know how to calculate the standard error. And so this is a formula that we will use. We will have to calculate this outside of StatCrunch. We will be in charge of this one a lot. So we will take the square root of whatever that p-value is, that percent, its complement, 1 minus that, over the sample size. Okay, let's put these couple ideas, and this formula specifically into effect here. Okay, it says, according to the Mars Company, packages of milk chocolate M&Ms contain 20% orange candies. Suppose you examine 100 random candies out of a large bag that contains several thousand M&Ms. First, we want to check those conditions. Okay, condition number 1. You're just looking for the key word. Was this randomly selected? The key word is here. So random selection, Check. Condition number 2 says, is the whole population that you chose from greater than or equal to 10 times the sample size? Well, I know for a fact my sample size is 1,000. Is 100. My sample size is 100. So what I have over here is 1,000. Now, where did I choose these from? What was my whole population? My whole population was this large bag that contains several thousand M&Ms. So I guess the question becomes, is several thousand greater than or equal to 1,000? I would say yes, it is. So we are good on that. Okay, what value should we expect from our sample percentage? So if out of these 100 candies, how many of them should we expect to come out 20%? Remember, because we hit those 2 conditions, we expect to hit the real value, the true value. So out of my sample, I should expect to hit this value. I should expect 20%, the true percent, or 20 of them, depending on how they ask. If they ask you, this one asked for the sample percentage, so I would answer with 20%. If it said how many, I might say 20 out of the 100. Either way, just depends. Sometimes sometimes Miles Plus asks for it differently. And finally, what is the standard error? So again, because we have hit that condition, we have this formula, P1 minus P over N. Can just set this up. The p-value is 20%. Sample was 100. So I've got the square root of 0.20 times 0.80 over 100. Can calculate that out. See, I've got my paper here. That should come out as 0.04 or 4%. Please make sure that you know how to type this into your calculator correctly in order to get this result. Different calculators are going to accept that with different ways. Some of you may have to put some parentheses in different places. So just get to know your calculator. Try it out until you're able to get to this correct answer. Okay, so kind of putting that all together, we should expect then 20% orange candies, give or take 4%. That's what the standard error means. Standard error is that plus minus amount. Or another way that you might be asked to give this is between how many and how many. So maybe we might say between 16% and 24%, because we might take the 20 minus the 4 and the 20 plus the 4 in order to get that. And that concludes the 7.2 notes.